students of second year Bachelor of Business Computing, we are having lectures in systems analysis and design. This is one of the courses you are going to do this semester. And before I start the lecture, I want to remind you of the following. Please access e-learning platform for this course from MOOCSEP. When you go to the site, you will find some materials for this particular lecture. There's handout 1. There's also summarized content of the presentation in PowerPoint. And the course outline is uploaded on the site. So make sure you access the site and you attend the online classes. So for today, we're having the first lecture. This is the content we're going to cover. The first is introduction to this course. We'll have some definitions, common ones, we shall be using from time to time. Then we are going to discuss the importance of studying information systems, especially in the context of systems development. We shall look at stakeholders in information systems development work. And out of a number of stakeholders, we shall single out systems analysis and design, special person called systems analyst. We shall discuss the details of the analyst, who this person is, what he or she does. And after that, we'll look at ICT Steering Committee. This is a special committee to oversee an ICT project. And then we shall also discuss reasons for information systems projects. Why should we study these projects? Why should we get knowledge for these projects? And then that will be followed by systems development life cycle, software requirements. And then there are some frameworks for requirements. One of them is what we call Pieces framework. We shall define that abbreviation, Pieces, and discuss it. And finally, this lecture will be ended with the COSAS model. This is also a framework for systems work. So here are some common definitions. Information system. We say this is an arrangement of people, data, processes, information presentation, and information technology that interact to support and improve day-to-day operations in a business, as well as support the problem-solving and decision-making needs of management and users. You know, the digital revolution has shaped the world. It is ongoing because new technologies continue to evolve, and these technologies support and affect the way we do work. That's why, for example, you can see we have gone for online classes. This is enabled by ICT. Therefore, when we talk of information systems, we bring people, we bring activities, what we call processes. The data, you know, is the nucleus of everything. And also the technology itself, the hardware, the software, and so on. Then we can also talk about IT, which is common. You know, there's IT, there's also ICT. They may not be exactly the same. So we are saying information technology is a contemporary term that describes the combination of computer technology, which is hardware and software. And in addition to this, we also add telecommunications technology, which captures data, image, and voice networks. Now, we can summarize components of an information system in this diagram. There's a diagram you can see. On sides, you see people resources, data resources, network resources, hardware, and software resources. And then at the center, that diagram at the center is presenting the summary of what actually happens to data. What happens to data is summarized at the center of the diagram. You have input, processing, and output. So this input can come in a variety of ways. It can be received by, for example, even mobile phone. When you text, that is an input with the keyboard or the smart screen you have there. Or you can use the computer keyboard. Or you can even capture picture using digital camera. That becomes the source of input. Then it may be processed or transmitted to get the final output. So, in summary, those are the resources we can look at one by one. People can be end users. We're all end users of information systems. For this lecture, you are the end users. Then you also have information system specialists, the professionals who are charged to do information systems work, the database administrators, network administrators, programmers, and many. You have hardware. This can be the physical computer hardware or media in general. Then you have software. These are programs and procedures that give logic for the operation of an information system. You have data. You know, data is central in computing. In computing, data is always there. Just like when you are studying chemistry, the focus is chemical reaction. There can be chemistry without chemical reaction. Also, when you are studying physics, energy always comes in. So for computing, data is central. Then computer systems are characterized by networks. We're able to communicate because of the existence of networks. These networks can come in a variety of forms. For example, for mobile phones, for this e-learning, there must be network to support it. Then all this to perform input, processing, output, storage, and control activities that convert data resources into useful products. Now we're going into details of the components of an information system. So we have specialists. One of them is systems analyst. We shall look at the role of systems analyst because this individual plays an important role in information systems work. Then we also have software developers and system operators. And then you have end users. You know, an end user may not be a technical person in ICT, but this person still depends on ICT for services. So anyone else who uses information systems is an end user. And then hardware resources, when we talk of machines, we are referring to computers, video monitors, magnetic disk drives, printers, optical scanners. And then when we talk of media, you know, in the past, we used to have what we call floppy disks. But as technology developed, these ones are actually phased out, but they're still there in ICT areas, especially for storage. Magnetic tape, optical disks, plastic cards, paper forms, flash disks, and so on. So those are hardware resources. You also have software resources as one of the components of an information system. So when we talk of software resources, we look at programs, and from programs, we can have operating system programs, for example, Windows, Linux, Unix, and others. You have spreadsheet programs. Some of them we call them application software. For example, spreadsheet programs, word processing programs, payroll programs, and so on. And then there's also procedures for data entry, for error correction, for paycheck distribution. These can be examples. And then data resources, you can have, for example, product descriptions for a business organization, or customer records, employee files, inventory databases, student files, medical files, and so on. So under network resources, still as one of the components of an information system, you have communications media, communications processors, network access, and control software. Networking is an important part of ICT, creating a global village. And you can also have a very simple network. For example, network in computer lab. Or you can even create what you call peer network using 2, 3, 4, or 5 computers, or even more, without a server. Those are still network resources. And then you have information products, for example, management report, which can be a printout, business documents, using text and graphics displays, audio resources, or even audio and video, multimedia, what we call multimedia, and paper forms. Those are information products. Now, the next topic is in form of a question. Why study systems analysis and design methods? This course, we teach it to you as BBC2 students. We also teach the same course to MBA students. Those are people at the managerial level. It's still important for them to have the knowledge of systems analysis and design. So this is the key question. Why study systems analysis and design methods? The first point, we have to note that information is a resource. Many businesses consider management of their information resources to be equal in importance to managing their other key resources. For example, property, facilities, equipment, employees, financial capital, and others, depending on departments in that organization. So information must be managed professionally. It is a resource. That's why we develop interest, and we have to give all this time to see how information systems development process can be managed. And then the second point to note is projects do not succeed by chance. There are very many ICT projects that have succeeded. There are also very many that have failed. And unfortunately, for the ones that fail, they normally fail after consuming a lot of organizational resources, especially money and time. There are organizations, including government organizations, that have acquired ICT, they procure. When it comes to implementation, things don't go as expected. So you see total project failure. So we need good knowledge, we need good understanding of systems design methods, systems work, systems implementation, systems maintenance and support, so that we are in position to direct ICT activities in organizations. And then the next point particularly goes to developing countries, the additional causes of IT project failures. The first is perception that hardware alone is the computerized information system. Sometimes people think that when you go to shop, you buy computers, bring them, put them in offices, that is everything. No. The key question is, why are you buying these computers? Do you have any agenda for them? What are they going to do? And unless that question is competently answered, the assumption is always going to be that having hardware alone is already a computerized system. No. Hardware acquisition may be 20% of the overall computerization system. The most important thing is going to be what it drives the business. How can we use these hardware resources? Which software do we need to install on them? Those are the key questions that must be answered by an organization. And then another big problem, more so with developing countries, is high level of corruption. Sometimes ICT projects fail because of corruption. The corruption can come in many different aspects. For example, buying wrong hardware equipment, buying wrong software, the software that is not going to serve an organization, or there can be problem in procurement process. A hardware which is supposed to cost 5 million may be elevated 10 times to become 50 million. So that can be a problem. And then there's fear of technology. Technology, especially ICT, must go into hands of everybody. All the users should be part of it. Unfortunately, sometimes people who are at high level, that is managerial level, they throw ICT to ICT operators. They say handle this. No. The key decisions will be made by managers. They are the ones who are responsible for planning, approval, so they should be part of it. So we're next looking at stakeholders in information systems development. Namely, these are system owners, system users, system designers, system builders, system analysts, and finally what we call IT vendors and consultants. So we're going to look at them one by one. Let's start with the system owners. System owners, these are the people who pay for the system to be built and maintained. They own the system, set priorities for the system, and determine policies for its use. In some cases, system owners may also be system users. When you look at, for example, Makerere University Business School, going to computerize some of its activities, the system owner may be government of Uganda. Through Ministry of Finance and Ministry of Education, they can procure system for the institution. And then you have system users, actually use the system to perform or support the work to be completed. System users define the business requirements and performance expectations for the system to be built. Now, these, in most cases, are the employees of an organization. When you go to a bank, those tellers you see there, those are systems users. Any organization you visit, people you find performing tasks using computerized system are system users. Even when you are registering online for a semester, you are a systems user. When you go to a bank, you decide to withdraw or deposit cash using ATM machine, you are system user. So next you have system designers. So these ones design the system to meet the user's requirements. In many cases, these technical people may also be the system builders. You know, innovation actually comes in design. The creativity of the designer will give best solution. If the designer is creative, we are likely to see a new product coming out with the features we want. And then, out of the stakeholders, you have system builders. You know, when we mention the word construct, it's not building. We're not constructing building, but we're constructing software. This is programming. System builders are programmers. They also test and deliver the system into operation. And then you have systems analysts. You know, when you look at the systems world, in most cases, the users of computerized systems are people who are not technical in ICT, but they use it. And they are the ones who can communicate what the business wants. And then on the other side, you have the technical team, those who program, those who design. They may not be in the user team. Like there's a gap between the two. Those who are technical, who can build a system, and those who use the product. So we need somebody to bridge this gap between the technical and non-technical, and that is the systems analyst. So this one facilitates the development of information systems and computer applications by bridging the communications gap that exists between the non-technical system owners and users and technical system designers and builders. And then you have IT vendors and consultants. Now, these are business people. They sell hardware, software, and the services to businesses for incorporation into their information systems. Now, out of those stakeholders we have summarized, we are taking systems analysts, and we want to study systems analysts' work and characteristics into detail. A systems analyst studies the problems and the needs of an organization to determine how people, data, processes, communications, and information technology can best accomplish information for the business. This is the key person who directs systems development. The analyst should have the entire knowledge of the system that is going to come out, so that he or she is in position to guide all the parties involved in systems work. So these are the duties of systems analysts: to identify the problem of an organization, the problem that requires ICT solution. You know, this problem may come from a department. It may be an opportunity. Or there may be a system in place, but not working well. So the systems analyst should understand what is happening, identify the problem, then analyze and understand the problem well. Identify solution requirements and expectations. You know, when the analyst examines the problem, quickly this person can propose a solution. From experience and from available technologies in the market, this can be a feasible solution. But the analyst cannot stop there. The analyst will continue and identify alternative solutions and decide the course of action. The analyst is advised to come up with 2, 3, or 4 different alternatives, examines them, and finally says, this is the best way to go. Then based on that, the designers can be advised to design and implement the best solution. Evaluate these results. If things are not going well, if the problem is not solved, return to step 1, identify the problem. Or 2, analyze and understand the problem. So that's what an analyst is expected to do. So these are qualities of a systems analyst, qualities of a modern systems analyst. You know, it's an interesting career which you can pursue. Then if you are preparing for that, these are the expectations. Working knowledge of information technology. The analyst will be somebody who has passion for ICT, is ready to learn new technologies as they come. With this knowledge, the analyst can be in a good position to guide and advise an organization. Computer programming experience and expertise. It's important an analyst has programming knowledge. May not be fully involved in programming as such, but should be able to guide or advise programmers wherever they are and what they're doing. Then general business knowledge, knowledge of management, knowledge of accounts, knowledge of business law. You know, all these are important aspects of information systems development. Then problem-solving skills, the ability to break down a complex problem into smaller parts. You know, that is dividing the problem into smaller parts so that the management of the entire problem becomes easy. Problem-solving skills is an important aspect of analyst. And then interpersonal communication skills. The analyst is expected to communicate well. You know, this person is going to interface with the non-technical team, the owners, the users, and also interfaces with the technical team, the designers and builders. So the analyst should communicate orally and in writing. Should be able to explain, should be able to manage disputes amicably, should be able to get resolutions, should be able to get a system going on. Another quality of systems analyst is interpersonal relation skills. Interpersonal relation skills. You know, psychologists divide us into 2. There are people who are introverts and there are people who are extroverts. The extroverts, they normally talk a lot. They make friends or they build friendships easily. But in most cases, they tend to be unreliable people. Then the introverts, on the other side, are quiet. These guys like reading books, and it takes time for them to make friends. And once in friendship, the friendship tends to last for long. Now, we expect the analyst to be an extrovert, minus those negative aspects of an extrovert, so that he can communicate and relate to everybody. Then flexibility and adaptability is another quality of systems analyst. It's almost impossible to see two projects that are related to each other 100%. No. Organizations differ. An analyst might have implemented a project in one organization, and after that is called to implement another project in another organization. So this analyst should be flexible to adapt to new situations. Should be able to identify new problems and opportunities for the next organization. Then finally, we're saying an analyst should be a person of character and ethics. We want a systems analyst to have strong character, not a weak one. And when we talk of ethics, we're referring to the ability to differentiate between right and wrong, and of course, to go with the right. Information systems may involve access to confidential documents of an organization. So an analyst must not leak whatever is confidential for an organization to third parties. Otherwise, that will create problem in the systems work. So next, we are looking at systems development life cycle. Actually, this course of systems analysis and design is summarized by systems development life cycle. And a good understanding of systems development life cycle reflects overall knowledge of systems analysis and design. Let's start from definition. The systems development life cycle is the process of understanding how an information system can support business needs, designing that system, building it, and delivering it to users. So it has life cycle. There is beginning, there is an end when the system goes into productive use, and after that it enters what we call maintenance phase, the support phase. So phases of system development life cycle. There are 4 important phases. We should get these phases clear and get to know what is involved in each phase. And the first phase is what we call the planning phase. So under planning phase, there are 3 important aspects we should look at. The project initiation, the feasibility phase, and finally, project management plan. There should be a problem to start systems work. Then the question is, where is this problem coming from? It may come from a department. It may be for the entire organization. That is what can prompt systems work, systems development work. Then, when the problem has been brought on table, the next question is, if we computerize the system, are we going to make losses or shall we gain after computerization? And to answer that question, feasibility study comes in. Computerization exercise can be very expensive. But after spending all this money, we want to see returns. We want to see gains. We want to realize profits. If we are going to spend all the money on computerization and we make losses out of that, then it is not worthy to have it. So that calls for what we call feasibility study. And this feasibility study comes in 3 parts. The first is what we call the technical feasibility. And the question is, can we build it? Do we have the knowledge? Do we have the technology? Do you have the hardware? Do you have the networking equipment? Do you have the relevant software? The second is economic feasibility. If we build it, will it provide business value? If we build a system, and if it is going to cost maybe 800 million Uganda shillings, when this system is put into productive use, can we get returns on it? Are we going to generate income using it? Is it going to increase the customer base? So that is under economic feasibility. You have to do cost and benefit analysis. If the cost is going to be high to come up with an information system, then if the benefit is going to be low, it's advisable you don't proceed. But when you weigh the two, cost and benefit, if the benefits are going to be high, go ahead and computerize your organization. Then the next is what we call organizational feasibility. If we use it, if we build it, will it be used? If we build this system, are the employees, are the system users going to be active in using it? Look, as an example, with this COVID-19 pandemic, all the institutions in the world, at most levels of education, more so university level, have realized that, and it has become reality, online learning can proceed. With the physical face-to-face learning, it's a big challenge. Life comes first. You have to save the life. Then the question of organizational feasibility is, if we build this system, if we make it available, those who are supposed to use it, are they going to use it? Unfortunately, sometimes organizations invest heavily in ICT, and at the end, users don't use it. So, the way forward is to have systems at a place and to ensure that those who are supposed to use it are using it to do what they're supposed to do. Like for our case, attending lectures is online, accessing content is online. As I said, life comes first. Protect yourself, but advance with your education. This is what is happening in the whole world now. And then, for planning phase, the last part is project management. Now, if the feasibility report is okay, and we're justified that the benefits are going to be more than the cost, then next thing is to come up with a project management plan. How many people do we need to build this system? What is the budget? What is going to be the time frame? So all those can be documented in project plan. Then before we proceed, I want us to look at Information System Steering Committee. This is also an important committee for ICT system right from the beginning. Actually, before the systems development process takes off, this committee is formulated, normal by the overall management. So the responsibility for overall strategic planning and the control of computer systems development will usually reside with a standing steering committee. This committee, in most cases, comprises members coming from different departments, maybe IT, finance, human resource, the user department, and also individuals from technical team who are going to implement this project. Its aim is to ensure that the information systems in the organization deliver an effective service compatible with the cost efficiency. So they have to plan this in advance. So the purposes of the committee may lie within the following areas: to recommend an overall policy, information and data processing systems development. We mentioned this earlier. When we were looking at the stakeholders, we said there are those who own the system. So this committee is set by the system owners to ensure that individual user department needs are being satisfied. To capture all the requirements, this will ensure that. To initiate and monitor individual projects. The project has scope, it has budget, it has its objectives. And when the project takes off, the steering committees will ensure that everything planned, everything agreed on are going well. To coordinate individual projects. Individual projects that will affect one another must be made aware of this in order to ensure harmonious development. It is also important that projects are not viewed independently, but taken together as a strategy. An organization may be having a number of projects that are concurrently going on. So the steering committee should ensure that these are moving on harmoniously. If one is contributing to other, then they should ensure that the network is consistent. To report upwards to top management, management will need summary reports on project development, the present and future costs. They report to decision makers. They report to the board of directors. They report to the council of an organization. To be responsible for the appointment of senior personnel in the computer center, job specifications and appointments will be decided at this managerial level. So the participants in the project work, the technical team, will be appointed by the steering committee. Let's still look at reasons for project initiation. The following are among the common, these are the most common ones. The current system cannot cope. Sometimes systems have limitations. Many systems, projects replace old systems. The previous system may have been a manual system that is paper-based 100%, or it may be computerized but having problems. Either way, it may not have been able to cope with the demands on it. Cost savings. One of the most common reasons for the earliest computerization projects was the replacement of time-consuming and therefore expensive manual, rule-governed, repetitive procedures for quick, cheaper computer substitutes. If the existing system is frustrating its users, if it is frustrating the entire management in terms of cost, then there is need to call for a new one. the provision of better internal information for decision making. Management has recognized the ability of computers to supply fast, accurate, and targeted information. If management decisions are analyzed for the information requirements, information systems can be designed to enable more effective decisions to be taken. Again, problems associated with this can be overwhelming information. Sometimes information available is too much, and management may not know which course of action to take. Therefore, it's important to get understanding of the needs of particular business direction. And based on that, the right information can be captured, analyzed for decision making. The provision of competitive customer services. This may range from fast inquiry services and clear itemized bills to customer-operated input or output equipment. So customers need to be serviced at the right time. They need to receive what they want, and they need to be communicated to if they are having problems. So ICT can enable that. The opportunities provided by new technology. Computers come, they can stay for longer than other technologies. For example, cars you have around. The lifespan of a car may be small, but ICT matches, it changes now and then. When you buy a computer system, if you maintain it well, it can last for years and years. And opportunities can come for new business directions. Just look at the way how ATM machines came to Kampala. Initially, there was only one bank having one ATM machine in the entire city. And then when other banks saw this ATM as an opportunity for banking industry, they started adopting it. And this time, even they are branchless banks. The bank that is existing with the ATM machine alone. So it has gone everywhere. That was an opportunity. Then high technology image. There are companies that want to build their brand on technology so that customers view them as service providers who are having services driven by technology. Or there can be changes in legislation. Changes in legislation such as data protection legislation may act as the trigger for new systems development. Or even, for example, the government may decide that for a bidding process, people should bid online. If there's a business organization that has not been paying attention to ICT, then they must change. Otherwise, they go off the business. So planning has been long. After looking at planning phase, with the feasibility study, project plan, problem initiation, we looked at other stakeholders who can also come in the planning phase, especially the steering committee. Then after that, we looked at into more details, the aspects of problems that can call for computerization. So next is the analysis. The analysis phase answers the question of who will use the system, what the system will do, and where and when it will be used. During this phase, the project team investigates any current systems, identifies improvement opportunities, and develops a concept for the new system. This phase has 3 steps. So we should capture 3 important activities under analysis. So the first is what we call the analysis strategy. This is developed to guide the project's team efforts. So I want to mention 2 important terminologies. The as-is system and the to-be system. The as-is system is what you see now, what you see as it appears. What you see at its current state is the as-is system. And then the to-be system is your dream system. This is the system you want to see, maybe after 1 year, if the project team does its work successfully, or after 2 years, depending on the time schedule. So the to-be system is the new system. This system is not with us, but is something we're going to work on. And then the next is the analysis, system concept, and the modules that are combined into what we call system proposal document. And this is presented to the project sponsor for decision. The design. The design phase decides how the system will operate in terms of hardware, software, the network infrastructure, the user interface, forms and reports, and the specific programs, databases, and files that will be needed. And again, the design has important aspects to note. The design strategy. What's going to be your strategy of design? It may be in-house systems development. Now, this is a situation where you have ICT department in your organization. You have programmers, you have designers, and you have systems analysts. And all these are employees of an organization, and they are going to build the systems themselves in the organization. That's why we call it in-house. Then if you do not have this department, or if you have, and they may not have the capacity to do the work, the entire work, you may outsource. So for outsourcing, you have to come up with a document which you address to companies. Outside there are IT companies that can do the work for you, that can design, program, test, and install the system in your organization. So that can be an ICT company. Or if you still fail to get this company, the last option is what you call the buy solution. You purchase the software. You go to a shop or you contact a software vendor for a solution that is ready, so that you buy this for your organization. They customize it to the needs of your organization. Then another important aspect of design is the basic architecture design for the system. That describes the hardware, software, network infrastructure that will be used. And it will also bring clearly how these are linked, how these are coordinated based on the user scope for that system. Then you can have the database design with the file specifications. Then the analyst team develops the program design, which defines the programs that need to be written and exactly what each program will do. So after design, the fourth and the last phase of systems development life cycle is implementation. This is collection of deliverables, architecture, interface, database, program, and so on. So under implementation, you have three important aspects to consider. The first is system construction. This is programming. The programmers translate the creative design into a working software artifact using what we call development environment. And for example, Visual Basic can be used to program the design, or open source, PHP and MySQL for web-based application, or Java can be used, or Python can be used to program. Then after programming and testing, there should be installation of the system. When you are installing a new system, there are a number of ways you can follow. You can choose from one. The installation may be done by stopping the use of old system and starting to use the new system on an agreed date. That is what we call abrupt or direct cutover, or abrupt or direct conversion. That is one way of bringing a new system. Just come up with a date. For example, on the 15th of March, we are going to stop using the old system and we shall start using the new system. That is what we call abrupt or direct conversion. Or you may wish to continue using the old system and start using the new system so that the two systems run in parallel. And we call that parallel conversion. You start using the new system, don't stop the old one. You use the new system up to when you are sure that this system is good for the organization. If it is giving good results, then you can stop using the old system. That is parallel conversion. Or you may have phased conversion. Sometimes we call this location-based conversion. If you are having an organization with 5 branches, you start at one branch. If you succeed, then you roll over to other branches. That is a phase conversion. Then another important activity under implementation is support plan. There must be support plan. How is this system going to be upgraded? How will it be supported if errors come? If new employees come? Can we have a manual for them? So those are the issues to be handled under support plan. So that was the systems development life cycle. So next we're going to cover software requirements. You know, requirement is an important aspect of software development. Many times, software that is delivered is rejected by organizations. Why? Because user requirements are not satisfied or they are not met. If the requirements are captured accurately, if the programmers translate these requirements from the design into the actual program, then you can have success story. And because of the importance of requirements, we normally pay special attention to requirements discovery. So requirements are a specification of what should be implemented. They are descriptions of how the system should behave or of a system property or attribute. There may be a constraint on the development process of the system. So that is the definition of requirement. What we expect to see, the behavior we expect to see, the attributes we want reflected. So there are 3 levels of requirement. Take note of these 3 levels. The first is what we call business requirements. These represent high-level objectives of the organization or customer who requests the system. An organization has strategy, what we call strategic plans. These are normally formulated to exist for 5 years. And in that plan, how does software come in? It should originate from strategic level. So in that business requirement, systems will come out. Then the next level is what we call user requirements. These describe user goals or tasks that the users must be able to perform with the product. User requirements are tasks performed by employees of an organization on day-to-day basis, or what we call a routine basis. And then the last level of requirements is what we call functional requirements. Specify the software functionality that the developers must build into the product to enable users to accomplish their tasks, thereby satisfying the business requirements. So, this is summary of requirements development and management. Requirements engineering is actually taken as a discipline in systems work. So you have requirements development. Under requirements development, there's what we call requirements elicitation. That is to capture what users want, to capture what employees want. We call that elicitation. Then there's requirements analysis, requirement specification, and management. And even final requirements management is taken as an independent body that must handle, for example, change management. You know, for analysts, for systems analysts to deliver, to work effectively, to satisfy what the business needs, there are some tools that govern the work of systems analysts. And we are bringing 2 important tools. The first is what we call PCS framework. Then the second is COSAS requirements model, which we shall look at after this one. So that PCS is actually an abbreviation. The PCS framework focuses on the actual work of doing requirements determination. This model is used to identify the requirements into one of 6 subject areas. So in that PCS, P is standing for performance, I is standing for information, E stands for economy, C stands for control, E stands for efficiency, and S stands for services. So performance handles questions that address how the system needs to perform for the user. Issues of throughput, that's the amount of work performed over some period of time, and the response time, the average delay between a transaction or the user request and the response to that transaction or user request are considered. You know, sometimes we complain. We say the network is slow. Or if we try to access email, we say the email is not opening. And so these are problems associated with performance. So in the same way, the expectations for performance must be captured from managers and from the user department. Then the second category is the information category. And this provides the basis for the information or data model that the system needs to maintain. Issues dealing with the input data, output data, and the stored data are considered. When users are communicating, or if the system analyst has session with the user community, the analyst is going to capture a lot of data randomly. And when this data is documented as it is captured, may not be meaningful. So this framework can help the analyst to categorize the data captured. So one way is performance, the second is the information category, so the third is the control. Control category is associated with the system security issues, as well as the editing required on the incoming data. When we talk of security, we refer to things like password, biometric for verification of identification, and other security features. So, as the systems analyst gathers system requirements from the users, there are some requirements that are going to fall under this control category. So the analyst should document them under control. Then efficiency is a measure of method correctedness. Are things being done right? Efficiency impact is done in at least one of the three levels. Can be corporate, wide, department, or even individual. So the question is, can I perform the right work with this system? Are the requirements okay? Is the speed okay? Are the interfaces good? Is it user-friendly? Then you have the last category, that is services. These refer to functional requirements of the system. What does the system need to do in order to solve the problem? What processes need to be performed? Ease of use, and the needed support for ongoing use of the system, maintenance of the system, and training and documentation requirements. So services are those aspects that are performed by employees or users on a daily basis. So user requirements can be captured under services. The system should be able to compute this and that, should be able to reply to this and that, and so on. So next is COSAS requirements model. COSAS requirements model is the third framework. It too focuses on technique useful to a systems analyst doing requirements determination. COSAS requirements model uses quality management system approach. Organizations following a quality management system approach normally have mission for their existence, reason for their existence. They have goals to achieve. They have objectives which are derived from the goals. And when information systems are built, they are built from the mission, goals, and objectives, and the tactics and the needs of the organization. Objectives must be smart. They should be achievable. They should be measurable. They should be mathematically expressed. They should be quantified. So for business tactics, these are specific actions that are taken to realize the business objectives. How are we going to achieve the objectives? Which methods are we going to adopt? Those refer to business tactics. Then you have your information systems objectives. Information system accomplishments, for example, printing of reports, displaying calculations, and so on. Now, this diagram is summarizing the entire work of a system. You can see from up, focus on people, focus on object, that is information system, and then focus on development. And down here, you see vendors and consultants, suppliers, systems analysts will look into detail. You can see working with all those stakeholders at the one side. And then the work that is supposed to be done is from the other side. Then you have the business logic in the middle. So those are the references you can always read, but you have the handout for this lecture that is already online. Please download it and read it. We end here for this lecture. Thank you. Meet you again. Goodbye.